Welcome to this video tutorial, which is the introduction to a series of videos on problem solving. This video aims to explain what we solve as problem, how we solve them, and to take a case example to apply the how of the solving process. The problems we will solve are mainly problems related to competitive programming, which may involve topics such as sorting, searching, graph theory, dynamic programming, recursion, game theory, debugging, and so on. These problems will mainly be found on coding platforms such as HackerRank, HackerHead, Codility, or any other platform where we can find interesting problems. How are we going to solve our problems? We are going to solve our problem using a specific approach. The first step is to repeat the question. For sure, during the video, we are not going to repeat the question more than once, but when using the approach, you should repeat the question enough until you really understand what needs to be done, so you don't take the wrong path. Once we understood the question, we move to the example step, where we have to write down various examples showing input and expected output. We can use a two-column table to do this. Some program will provide us with such example. We can use them and add our own. Once we have our table, we can move to the next step, which is describe the approach. This is where we will set up the workflow we think we will use to solve the problem. When the approach is clear, we can move to the next step, which is the code. This is where we will properly write the code. When the code is finished, we can now test it to make sure it solves the example we wrote earlier. So we are going to run our code against the input we wrote earlier and make sure the code returns the expected output. Once this step is complete, we can move to the next step, which is optimization. Depending on the problem statement, we may implement some optimization. We may find ourselves with the code solving part of the problem test cases, and we will make use of optimization to ensure that our solution pass all cases. And the pattern actually stands for the Reactor approach. So you have the link in the description to learn more about the Reactor approach from its author. So now let us implement the process we just described. The first step of the process is reading the statement. We have our statement here, and it's something easy. Let us read. Tarek is a beginner in mathematics and wants to know the sum of all positive integers less than or equal to a given number n. Help Tarek to find the best solution to solve his problem. The first line contains the number of test case t. Each of the following lines contain an integer denoting the number n. The output format for each of the test cases, print the expected solution on a new line. So now we wrote the statement. Now we can move to the next step, which is example. Now let us move to the next step, which is providing input and expected output to our problems. Let's say we have as input 2. What will be the output? We need all the integer less or equal to 2, which are 0, 1, and 2. If you want to sum all of them, it will give 0 plus 1, which is 1, 1 plus 2, which is 3. So the expected output will be 3. If you have 4 as input, we need to have all the integer less or equal to 4, which are 0, 1, 2, and 3. 3 and 4, yeah. So if you want to sum all of those elements, we have 0 plus 1, which is 1, 1 plus 2, which is 3, 3 plus 3, which is 6, 6 plus 4, which is 10. So from here, we have a set of 2 input and expected output. Feel free to do more than this, and in our case, we are going to end here and move to the next step. So for the next step, which is describe the approach, we are just going to make use of how we made to move from the input to the output. For all of the input, what we did is that we move from 0 to the input, and we sum all of the elements we meet on our way. So the approach here will be, first of all, read the number of test case, and from the number of test case, write a loop that will cover all the test cases. And for each of the test case, we are going to move from 0 to the input and sum all the elements we are going to meet on our way and print the result as the output, and that will give us the expected output. So the approach has been described properly. So let's move to the fourth part, which is the implementation of the code. The code is basically the transcription of what we describe as the approach. So for that, we are going to make use of HackerRain platform like HackerRain compiler. We are going to write our code here and run our code against custom input, which we use our input and waiting for the expected output we just wrote at the step 2. Okay, so for the code we are going to use C++. Most of the problem we are going to make use of C++. So let's write the code here. So we need this to perform basic input output operation. Okay, like in the approach we said, the first thing we need to do is to read the number of test case, and to read the number of test case you need to have the variable declare. So we are just going to take it as an int, and we are going to read it. And from here we are going to loop from 0 to the number of test case to make sure we take all the test cases, and to do that we are going to use a for loop. Once you have the for loop here, the next thing we need to do is basically read the input of each of the test case. So to read an input, we need to have the variable declare also. I will say n, and we need to have a variable sum that will sum all the number we are going to meet when looping from 0 to n, like we just said before. We need to initialize this to 0. So from here we need to read the input, which is this. Once we have the input, we need now to loop from 0 to n to have the sum we are expecting to have. So I'll go like this: less or equal to n. Why am I saying less or equal? Because we said we need number less, the sum of all number less or equal to n. So from here we can now make this, and once we are here, after the for loop, the sum we have the expected output, we can now print the sum here. And since we want to print all the result on new line, we are going to make use of this. Now let's run our code against constant input. Let's take the input from what we describe as example. This is what we describe as example. We have 2 as input and 4. Let us take it. Number of test case 2. The first one is 2, the second one is 4. Let us run. And yes, it is working. We have 3 and 10 as output. So things are working perfectly now. So we just perform the fifth part, which is the test. Now let us move to the last part of our problem, which is the optimization. So the optimization is basically make your code work better, like perform the tasks the code is doing in a better way. And for all the problem we are going to face, since we are going to use a platform and we are going to run our code against a bunch of test cases, the optimization will always aim to make all the test case green. So in this case, we are not running our code against any platform test cases, but I just want to share with you an approach how to optimize the code. So let's have this. For this implementation, the first thing we are doing is that we are reading input from You are reading input from the number of test cases, which is something basically you cannot optimize. And from here, you are doing a for loop. Since for each of the test cases, you need to have an output. So basically, you cannot optimize this. You need to have this for loop. Now come to this for loop, which is meant to compute the sum of all the integral we are going to meet from 0 to n. This process can be optimized. And to optimize this, we can make use of a arithmetic formula which help you to compute the sum of consecutive integral. So what will it look like? It will look like sum equals to the first number of the series, which is 0 in our case, plus the last number of the series, which is n in our case, times the number that you are moving from the first one to the last one. Okay, yeah, if you are moving from 0 to n, you have n plus 1 number. Like if you move from 0 to 1, you have 0 and 1, which are two numbers, right? So this is it, and you divide it by 2. From here, the sum will be the expected output. Let us compute and see what it gives. Let us compute again. And then. And yes, we still have the expected output. So we are not making use of a for loop to have the sum. We are now making making use of a constant operation, which move our algorithm from big O of n to big O of 1 to compute the sum. For sure, for all the problems, the optimization won't be the same. It will depend on the problem statement. It will depend on the approach. So you definitely need to subscribe to make sure you really catch up all the optimization trick we are going to implement through the process of solving our problem. I hope you enjoyed the video. Feel free to subscribe if you like the video, share the video, comment. I would really enjoy seeing your comment and chat with you against all those problems. Thanks.